Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside, and we are going to begin a new unit here involving rational and radical expressions and equations. What are those? Well, think of rational expressions as things involving a fraction, more so when you have x in the denominator, and where it can happen, and also in the numerator as well. But where you have it in the denominator there, they are no longer polynomials. No, x is only in the numerator. Radical expressions and equations are when you have the little square root or a cube root or whatever it is, and we'll be dealing with those. So a little more advanced than anything else. Hey, get used to fractions, they're going to happen. But this particular video here is going to involve some factoring as well. So we just came off some factoring, and I'm going to assume you know something about the way that I've been factoring as well. I will go as quickly as I feel that we must when it comes to it. And I only have 8 practice problems for us to do here, where we multiply and divide rational expressions. So that's what this thing's going to be all on, in simplifying rational expressions here. Probably shouldn't have titled it Simplifying Rational Expressions. This is from my last video, my bad. Probably shouldn't have titled it just Simplifying Only. So this is kind of a part 1, and we'll be simplifying also with addition and subtraction, which is arguably more difficult because you got to work toward common denominators. And there is involved multiplication straight up on there. So we'll be multiplying and dividing, 4 problems multiplying, 4 problems dividing. And dividing is really not necessarily harder. There are 2 little instances of things we got to make sure of when we do them, but we'll take care of them when we get them. Okay, simplify each problem. Simplify each expression here and state the excluded values. I'll talk about excluded values at the end and go back to what it has to do with at the beginning, and you want to probably pay note and important attention to them when we have them, but we'll simplify this. Simplify just basically means if there are things to cancel, we do so. And no, you do not, I want to tell you right now, you do not take 10n cubed over 10n cubed and divide and cancel it. That is not a thing here. What you have to do when you divide, in general, guys, is you have to make sure that you divide something that's a common factor, something that multiplies on top and bottom, something that can divide out of all terms within that quantity. All terms within there. And whenever you have a quantity that's a common factor or multiple, yes, you can divide those things out. Take, for example, before I do a problem, say that I had something like 3 plus 5 divided by 3. Can I just cancel out those 3's? Can I even turn them into 1's? No. 8 divided by 3 is not the same thing as 5 or 6 or anything like that. Those are different things. You have to make sure that you find a common factor within there when we go. And that's what we're going to be doing here. Okay, so on a problem like number 1 and anything else involved, what we're going to be doing basically, guys, is playing just a large factor game in all these things here. I can take n squared minus 1, and I'm going to ask myself, can I factor it? And again, if you've seen any of my previous videos, or if you just know something about the algebra, you know that n squared minus 1 is a difference of 2 squares. That factors into n plus 1 times n minus 1. And again, my goal here is to create products. Just things that can multiply out and find out if there's anything on top and bottom that can divide or cancel or however you want to put it. Now this is over 2, but more importantly, what I'm going to put here with this multiplication is ultimately, guys, when we're multiplying a fraction by a fraction, we can really put it all as one large fraction in the end, which I'll be doing. Now 10n cubed plus 20n squared is a simple kind of cubic in the way that there's a common factor. There's a 10n squared that can factor out of all of that, and ultimately I'm left with n plus 2. Again, I'm assuming you know something about that. Now on bottom, there's nothing I can do with the 2, but right here I have another 10n squared that's a great common factor here, and now I have n plus 1 that remains. So if I can rearrange things here for a moment just to kind of appease what it is that we have here, again, when you multiply fractions, guys, if I have some a over b times c over d, that's the same thing as a times c over b times d. It really can all be written as one fraction. So what I'm going to do is I'm going to rewrite all this as one fraction. And whenever I have something that's less of a quantity, more is kind of just a term, I like to write it in front. So I'm going to put the 10n squared in front, gladly, and then I'll put the n plus 1, n minus 1, and n plus 2. They're all together in the numerator, divided by. Now 2 times 10, n squared is 20, n squared. I'll go and put those together. I don't know if you need to or not right now. We could cancel things now as well, but let's just do that. And I have n plus 1 like that. All right. So this is all here, right? All divided. Now, if there's anything that's a common multiple or factor or something, we can assuredly divide, make become 1, and cancel. So for example, n plus 1 over n plus 1 is 1. Those are effectively gone. We're going to talk about that later. N squared over n squared, again, is 1, and they're gone. And 10 over 20 can reduce to 1/2, so 1 over 2. So ultimately, 1 times anything is just that thing. So I do have this n minus 1 here. I have the n plus 2, and this is all divided by 2. Now, you could argue, as far as simplification goes, that maybe we should distribute this back out. I'm not going to be too particular in that, but this is as simplified excuse me, as I can make this. Now, we're not fully done with the problem. There are some things I have to talk about here, but furthermore, you might be asking, well, wait, Mr. Robinson, if this 2, you could have canceled out this 10n squared of 10n squared. Yeah, I totally could have. I probably should have, could have, would have. I just wanted to show you just my appreciable way of how I might put things in order. But furthermore, you might ask, wait, why could I cancel these and I couldn't cancel these right here? That's exactly the thing, guys. This was a common factor. This was a common factor here that factored out of both of those when it comes to canceling, which they do. I did it later down the road right here. Just depends on your order of simplifying things. I would probably do things a lot faster when it comes to, you don't have to write it as one fraction. What I want you to recognize, though, is that, things on one part of the fraction here do divide on parts of the fraction here. I could easily say, for example, n plus 1 over n plus 1. Yes, these two are dividing, despite the fact that they're separated by multiplication. They are dividing, and I think that's one reason why I wanted to write this here. Maybe I won't write this as much if you can recognize that that's what's going on. If you feel comfortable there, that's fine. Now, here's the other part, excluded values. What the heck are they talking about? Here's what they're talking about, and this isn't the greatest first example to tell you about this, but here's what they're talking about. These are fractions. These are fractions, and we have mentioned probably in some past that there's a problem with dividing by 0. We are not allowed to divide by 0 under any circumstance at any time. Now, let me get rid of this kind of canceling thing here. Before anything canceled, and maybe we can look at it up here. Before anything canceled, and I don't often like to say the term canceled because I want you to know it becomes 1. But before anything canceled, there was a possibility that I could have substituted certain values in for n that would have given me 0. For example, if I substitute 0 right here in for n, actually here, let's look at it before all the canceling happens here, because you can see it all as one big fraction, right? Before right here, if I substitute 0 for n, what would have happened here? It would have become 20 times 0 squared times 0 plus 1. We already know about the idea of zero product property. If something times something times something equals 0, then whole thing turns into 0, right? 20 times 0 squared, it all turns into 0. And that's a problem. That's a problem because you end up dividing by 0. Division by 0, whether 0 on top or 0 on bottom, dividing by 0 is not an allowed practice. Division by 0, non-zero, I'm speaking too much. Non-zero numbers divided by 0 is undefined. And 0 divided by 0 is something that's called an indeterminate, which is something that we are running into right here. If n equaled 0, that would be a problem because we'd be dividing by 0. If n equaled -1, that would also be a problem. -1 plus 1 turns into this whole thing into 0 as well. There are problems with n here. So let me kind of get into those restrictions again. They're called restrictions as they put excluded values. Restrictions are if n equaled 0 or -1, because those are instances where we would end up dividing by 0. Now you might say, Mr. Robinson, wait a minute. I thought you said those things canceled. Those are gone. Look at the problem here. What if I substitute 0 now and -1 now? There's no issue here, Mr. Robinson. I don't divide by 0 anymore. You're right, you don't divide by 0 anymore. But they're asking you to simplify the original expression. You see, we're dividing a number by itself. What if I plug this thing in before they canceled? You get a 0 over 0. You still can't divide by 0, even with 0 on top. If we graph these, and we'll be doing graphs down the line, this is what would create what are called holes. And maybe you won't know too much about what holes are now. If you don't mind with me, guys, just kind of indicate for me right now that if we divide something by 0 that ends up canceling, it presents what's called a hole. Maybe it's not worth me mentioning right now. Maybe it's not. I don't know if I should be. But when you divide by 0 in something that cancels in a graph, it presents a hole. Maybe you'll thank me later that I did create the whole thing now. Anyway, spending about 10 minutes talking about that first problem I hope is okay, because I want to present some of the opportunities and things that we're going to be doing in future problems with deeper factoring. So here's the final answer. Here are the restrictions, the excluded values right there on number 1. Now, I'll get deeper into how we found out those values there in future problems, but I'm saying when we substituted in 0, you saw what happened when I substitute -1. Let's dive into number 2. All right, number 2, same kind of things before, guys. Let's just look for things to just factor. Let's just factor this thing out, right? Boom, 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 boom. So right here on top, I need to see if I can find 2 numbers that multiply to make 32 and add to make 12. That would be 8 and 4. So this is x plus 8 times x plus 4. Now on bottom, I have a common factor of 11x. If I factor out 11x, I have x plus 4. Now times, common factor of 8 on top leaves me with x plus 10. And on bottom, 2 numbers that multiply to make 80 and add to make 18 are 10 and 8. So x plus 10 times x plus 8. I think I'm comfortable with you guys, as long as you're comfortable understanding that anything on here on top can divide with anything on bottom. Let's go ahead and find things that can cancel. So x plus 8 over x plus 8, x plus 10 over x plus 10, and x plus 4 over x plus 4. We are just left with what all that remains is 8 over 11x. And that's what this thing simplifies to, 8 over 11x. And that would be it. There we go. Okay, now, restricted values still apply here. Once again, is there any moment in any time where I'm possibly dividing by 0, whether initially or after things cancel? So let's check this out. Let's go to this 11x right here. Here's a problem, and here's how you probably want to. Oh, hang on. And can't equal 0 or -1. There we go. Here's how I would probably do it. I would set them equal to 0, but not equal to 0. We'd say that, okay, denominator can never equal 0, so 11x can't equal 0. If 11x can't equal 0, then divide both sides by 11, x can't equal 0. There's one of them. Notice the ones that cancel are also problems, right? Because they're problems for the original expression. If x plus 4 can't equal 0, then x can't equal -4. And if x plus 10 can't equal 0, then x can't equal -10. And if x plus 8 can't equal 0, well then x can't equal -8. So you can see all the restrictions here. The restrictions here are, and I'm not going to put restrictions each time. I'm just going to say what x can't equal. X can't equal 0. Here, let's do this in order so I don't mess anything up. X can't equal -10, -8, -4, or 0. Those are all the restrictions on those ones. Now, 0 was one that still exists here. This would create later what's called a vertical asymptote. I'm going to leave that for later, but I do want to present what would be the holes. -10, -8, -4 would present holes. And again, the reason why these would be holes in the graphs, you don't know anything about holes right now, but the reason these would present holes in the graphs are because these were things that canceled prior to getting this final thing here. Anything that remains would give us what's called a vertical asymptote. Again, I'll probably, I'll point it out. I'll put VA for vertical asymptote. Again, I think I'm speaking over what it is that we're going to be doing with that down the line. But you've seen it now, and that's helpful for us later. What's important are the restrictions. Even if they cancel, you still got to pay note. You still got to pay attention. Some teachers will ask you to present the holes immediately, the things before you cancel, before you forget. And I understand that. I totally do. I just think it breaks the pattern, the flow in what we're doing. But again, some people forget them later. So neither's wrong. Neither's wrong. All right. Neither's right. Neither's wrong. All right, number 3, right here. Okay, factor once again, 7p plus 9. I can't really factor anything there, so I'm just going to leave it as 7p plus 9 on top. And then down here, and then right here, I can factor out a 2, and I get 3p minus 2 like that. Okay. Now down here, I have 3p squared minus 26p plus 16. Now we're going to factor this. And then I'll tell you something that I'm going to suggest to you later. Okay, first of all, 3p. Times p, right? If you've dealt with my stuff, then you know that's here. Positive product, negative sum is minus, minus. Now 16 can be 16 times 1, 8 times 2, or 4 times 4. With this, these being odd numbers and this being an even thing here, it can't be 16 and 1. It's either 8 times 2 or 4 times 4. You can try 4 and 4. You'll get -12 minus 4 is negative 16. That doesn't work. So you can try 8 and 2, and you can try either or. You got to get to a bigger number here, so I'll try the 8 here and the 2 there. So that would be negative 24 minus 2, and that worked out. And then let's go and factor this one. That's a 7p times p there. Negative product, so positive, negative. I don't know which one's which here with the negative sum. So 27 is either 27 and 1 or 9 and 3. I like to err more toward the 9 and 3 first before I kind of dive into big 27 and 1. I don't think 27 and 1 is going to work. 9 will be too big for that. Let's try 3 there, 3 and 9. That would be negative 21 plus 9. That's negative 12, and that one factored there. Perfect. Okay, now before I continue with this, I wanted to mention one thing about these problems. See, look, hold on. Let me kind of get rid of this text. The goal and understanding with these problems here, guys, is once we factor, there are hopefully things that will cancel out. Do you notice here that 7p plus 9 is going to cancel here? Is it canceled there? Do you notice that? Because I do. And the 3p minus 2 is canceled there. Now, I'll bring them back, but do you notice that they canceled? If you notice, and honestly, I didn't pay attention in other previous problems, but if you notice that there's something that's ostensibly like there, that's like, I couldn't cancel this. Why is 7p plus 9 existing? It's very likely that it exists as one of the factors in another expression that you have to factor. So while you're playing that longer factoring game with something here potentially, you can maybe cheat it a little bit and say, this thing has a 7p here. Do you think when I factor this, it's possible that maybe, because 7p plus 9 is here, that just maybe 7p plus 9 is one of the factors? And if it is, you can really play that idea. If this is plus 9, maybe, then to make negative 27, that would have to be minus 3. So there's a possibility that you find something like that. And you know what? That was true with the 3p minus 2 as well. Well, there's a 3p here. Maybe, just maybe, as a factor of 16 is 2, maybe this has to be a negative 2, in which case that would be negative 8. And that worked out for us here. So that might be cheating a little bit. Maybe you don't get to practice factoring as much. But that's a strategy that you can use here and consider trying. Maybe it doesn't work, but it's one that I would go for and check out just in case it does. And it does here. 7p plus 9 over 7p plus 9 is 1. 3p minus 2 cancels out right there. And I don't see anything else that operates here. We are left with 2 over p minus 8 times p minus 3. And again, I think we can happily leave it factored there. That would be the final simplification. Now, as far as restrictions go, what can't p equal? Well, I'm not going to go the full note of saying what can't equal 0 right there. If it becomes too much of an issue, we will. And I think there's some we might have to look at here. But p definitely can't equal 8 or 3 for now, right? P can't equal 8 or 3. But also, what are the things where it canceled? 3p minus 2 couldn't equal 0, because that would be division by 0 there. So if I add 2 to both sides, 3p can't equal 2, and divide both sides by 3, p can't equal 2/3. There's another one, and that's one of our wholes right there, because that was one that canceled where we divide by 0. Same thing here as well. 7p plus 9 can't equal 0. Subtract 9. 7p can't equal negative 9. Divide by 7p can't equal negative 9/7. And I won't always show this work. I'm just showing you where I got the numbers there. This time it doesn't look like they are in order. But those two are my wholes. These would be my vertical asymptotes. And one more time, guys, this is what you're going to see when we graph later. Probably a couple of videos from now, at least in this series. So vertical asymptotes there, holes there. Those are our restrictions on P. Okay, let me pause the video for 1 sec. I did want to respond to this message I got. Give me 1 moment. Okay, back without a hitch. Let's move to number 4. Let me move myself just because it's going to get a little... Oh, nasty. Look at this. All right, number 4. Now, this one is not as plainly obvious as far as what's there because nothing quite shows up. You know what? Maybe we can find ones that are going to be a little easier for us. Let's look at this bottom one first. And it's calling... Actually, this top one as well. But this one really calls my attention because I can factor a 2 out, and that leaves me with an m squared, a 1m squared, and that's good. Because that means when I start factoring this thing out, let's play with this right now. Two numbers that multiply to make negative 42 and add to make negative 1 are negative 7 and positive 6. So m minus 7 times m plus 6 comes here. And that's kind of nice because, you know, if we're looking to potentially cancel things out, you know, factor things, we got to see and ask ourselves, can an m minus 7 or m plus 6 ever show up in any of these things later? I don't know. I haven't done these problems before, so I couldn't tell you. But Potentially, right? Now, this top doesn't have a common factor of 2. This one did. I don't know if 2 is the largest number. I think it is, because here we got 5m squared plus, you know what? Never mind. Plus, what is that? 29m minus 6. And then, yeah, we're going to probably have to factor that one down more as well. Okay, so there's some deeper factoring that we're going to have to do. So I'll get that one. You want to do that one right now? Let's do that one right now. 5m and m with a plus and minus there. 6 is either 3 times 2 or 6 times 1, what have you, so we're not sure. It's not going to be an m minus 7, that's for sure. And m plus 6. Well, you know what? It's potentially m plus 6. Let's try this. If it's m plus 6, this would have to be 5m minus 1. Will that work? Will that work here? I'm trying to see if the m plus 6s can cancel. It's kind of cheating, but does it work? 30 minus 1 is 29. Yeah, that works. So see, there's me just kind of working a strategy and saying, is it possible that that's where the m plus 6 appears? I had to test it possibly at some point anyway, so why not test it first? And say if it's one that's going to cancel, see if it actually leads me there. And it did. All right, so 2m squared plus 31m plus 110. All right, that's a little bit larger of a number. The one that comes to mind for me first, of course, is 11 and 10, right? So let's try 11 and 10. 10 can't go here without a common factor. Let's try 11. Let's see if that works. 20 plus 11. Yeah, that's 31. So that one pans out right there. And then the last one here, where we have something with the m's, negative 11 here would be some sort of 11 times 1, right? Now, I don't see anything that would cancel on top with that so far. So let's try this. Let's see. Let's try 10m with m, some form of plus and minus. We're not sure what. But again, 11 and 1. 11 would be too big with 10 there, and 1. It's not going to be the 11 and 1. In fact, I know what it is now. Too big. Let's try 5m and 2m. Oh, you know what? 2m plus 11. 2m plus 11, right? There it is. That we're looking for that to cancel with a negative 1. 5m minus 1, of course. Why didn't I see this before? 10m and m never would have worked anyway. So 55 minus 2, that gives us 53. And that, yeah, that led me into trying that later, but I kind of saw that I wanted to get 55 with 5 and the 11 there. All right, so that's all the factoring there. Now what can cancel? 2m plus 11, 5m minus 1, m plus 6, 2 and 2, and we're left with m plus 10 over m minus 7. And just to kind of hit this home one more time, guys, no, you cannot cancel out the m's. Those are not common factors. Those are terms within a quantity. We need to just leave it like that. You cannot cancel out the m's. Okay, what can't m equal? I'm glad you asked. M cannot equal 7. As still, it cannot equal 7. M can't equal what else? M can't equal negative 6. That would present a whole, despite that canceled. If 5m minus 1 equaled 0, m couldn't equal 1/5. Add the 1, divide by 5. Add the 1, divide by 5. If 2m plus 11 couldn't equal 0, subtract 11, divide by 2. M couldn't equal negative 11 halves. These ones would present us with those wholes. And this would be the vertical asymptote of that graph, which you won't see for a little while. I think it's worthwhile that I'm mentioning those now. I really do. You say like, hey, I learned that before. All right, yeah, I'm definitely having fun with that factoring, guys. Okay, so that was multiplication with these things. Now we're going to do division. Now, the only two differences with division are this. Number one, we're going to turn it into multiplication. And number two, when we do excluded values, we have to make sure that we consider any denominator at any time. Anytime anything ever presents itself as a denominator, we have to consider it something that is of concern. Now, I want to turn this thing into multiplication immediately, but consider what was a denominator here and consider it to be something within our restrictions, our excluded values, okay? Don't forget the original expression when we do that. Just don't cancel anything when it's in division right now. I'm going to immediately turn this into multiplication, and as I do, I hope you don't mind, I'll also be factoring at the same time. So I'm going to do this times the flipped version of this, but in doing the flipped version of this, guys, I am going to factor. So so what I'm doing here, dividing a fraction is multiplying by the reciprocal. the reciprocal of the second guy, of the divisor right here. Here's the dividend and divisor. So common factor right here is 4k, and here I'm left with k plus 2. Common factor down here is 6, and we're left with k minus 3. Now here, I'm going to put this up top. So 6k minus 60. I'm going to factor out the 6, and I have k minus 10. And then on bottom, two numbers that multiply to make negative 20 and add to make negative 8 are negative 10 and positive 2. So it's k minus 10 and k plus 2. Okay, so I flipped this. I already flipped these things right here. Multiplication is where we can now present things as what's on top, what's on bottom in a true sense. So here we go. Now, I do have 6 over 6. I'm not going to bother multiplying 4 with 6 if I already have something I can work reduction on. I think that's taken care of. K plus 2 and k plus 2 are gone. K minus 10 and k minus 10 are gone. We're left with just 4k over k minus 3. Let me see if I got another text here. Okay, yep. All right, so I'm good, just an acknowledgement. 4k over k minus 3, and we're good. Now, restricted values here. Here's where we got to be careful. Anytime anything was presented as a denominator, anytime anything was ever presented as a denominator is a concern. Now, the only things that presented themselves as denominators before already canceled out, which means they were also on top 4. So when I look at, you have to remember, this was, and you know what, maybe we should factor before we flip. Maybe I'll do that next time, because anything that's set equal to 0, we want to know what it was. This, when I factor out 6, was k minus 10. This was in a denominator at one point. Doesn't matter that it flipped up here. Before we were dividing by something that was dividing by 0. And now that we multiply by something that's dividing by 0, whatever. But this was an issue, k minus 10 before. It still was an issue down below. Basically, k could never equal 10. And, that's one of our holes. K can't equal 10. That's going to be a hole. What else is a hole? Just because I'm stuck in the holes right now. Negative 2 is a hole because of that cancellation, that thing on bottom. K can't equal negative 2 at any time. 6 doesn't matter there. And then k can't equal 3. K can't equal 3 right here. Okay, now this problem and the previous problem, maybe some other ones before it, k can equal 0. There's no problem with k equaling 0 and me having 0 in the numerator. 0 divided by a number is fine as long as the zeros didn't cancel. So these are the restrictions here. The 10 and the negative 2 would present us with our holes, and this would be the vertical asymptote right there. So those are our restricted values. All right, number 6. Yeah, let's factor before we move forward so you know what was in the denominator before it flipped, if that's cool. I don't want to do 2 steps in one if that was too confusing. So number 6, factor out a 9, and we get r minus 2. This is a perfect square trinomial. This is r minus 2 quantity squared. I'm going to deal with it like that just so you can see what I'm going to do with this, but recognizing a perfect square trinomial when I see it. Let's keep it as divided by for a moment. I got 9, and then this is r minus 1. And then here I have 2 numbers that multiply to make negative 6 and add to make positive 1 are plus 3 and minus 2. Okay, now, one thing to be careful of. Do not do this. Because division is still afoot. Do not do this. Division is still afoot. You don't do that until it's multiplication. Multiplication would mean it's a true division of this by whatever's down there. But I'm going to leave this in this factored form, and I want to make sure that you can see that factored form right now, because I am going to flip this. I'm going to multiply by the reciprocal. Go ahead and flip it. But I want you to see what was in the denominator here before I flipped it over, so you know something that is an issue and is a restriction at some point there. So what are we going to get there? We're going to get, this is 9 times r minus 2. Something could cancel over here, actually. Over r minus 2 quantity squared times, and now we have r plus 3 times r minus 2 divided by 9 times r minus 1. Again, division by a fraction is multiplying by its reciprocal. And now we're going to find things that we can reduce and cancel. We do have 9 over 9 that go away straight up. Now, here's where, listen, r minus 2 squared does mean r minus 2 times r minus 2. And me putting r minus 2 squared is something of probably concern for some people. Some people would probably prefer to see r minus 2 and r minus 2. Here's what's going to happen. There are 2 powers of r minus 2 here. This r minus 2 can cancel with one of them, and you're still left with an r minus 2. And this one can cancel with the other. Great. And you're left with r plus 3 over r minus 1. R plus 3 over r minus 1. And again, there's no reason those r's can cancel. Give me 1 second. I have another thing with the message. Okay, sorry. Okay, where were we? I guess I simplified the expression. Okay, so what are we going to do? Let's find our restrictions here. What can't r equal? So this is why I put this expression here with division as well. At any time that we're seeing a denominator, we can't have 0 in it. There was a time when this portion here was a denominator. Doesn't matter that it came up here later. At some point initially, we presented it as a denominator value where we can have things that are undefined in that moment. So even though r plus 3 appears in the numerator here, and there's no problem with having 0 divided by something. There's no problem with r being negative 3 in an instance where you see this. But because at one point it was in a denominator, and when I put negative 3 for r here, I would get 0, that becomes a restriction. Now, I can't state for certain. I have to remember this for graphs. I do not know for certain whether that, I guess it's a whole. It's not an asymptote. So I guess it's a whole. I don't know which one that is. You know what? I'll check on that. I got to clarify that later. Maybe I'll put it in the comments section. I'll ask someone who does a bunch of calc because I'm sure that they know what that appears as a graph with. But it's an issue for the expression. You know what? It might not be an issue for the graph, but it's an issue for the expression right here. Something that I know for sure. But r can't equal negative 3 for that very reason. Right here, it was a problem. Right here, it was a problem. Okay, what are some other things r can't equal? R can't equal 1, clearly. That would give us that vertical asymptote. And anything else that canceled. The r minus 2, that gave us a whole. Kind of gave us a whole twice. One of those multiplicity of 2 kinds of things. R can't equal 2 either. That one's for sure a whole. This one is for sure vertical asymptote. And the reason I'm saying whole and vertical asymptote is these are graphical features. So I don't know if negative 3 ends up being a graphical feature as far as being undefined, but as far as the expression goes, I know it is for sure. Again, maybe check the comments or description section down below later when I can kind of get that resolved and figure out whether that's a restriction on the graph or just the expression. I don't know that answer. All right, number 7. Two more. Number 7 here, common factor, and let's do it with division first so we understand what was in a denominator again before we divide. Hang on, were there any other issues? Let me make sure. I don't think so. I just needed to make sure there's something there and anything that remained. All right, number 7, common factor of 12, and we have not n minus 4, 5n minus 4. Note that 5n minus 4, it probably comes back later. And down here, I mean, look, right here, right? Factoring right now. This is a 5n. Is this a 5n minus 4? Negative 4 times something is negative 12. Plus 3. Does that work? 5n times 3 is 15. Minus 4 is 11. Yeah, that works out. So that's me being, I don't know. You can still play with strategy all you want, but that's me, being smart with the problem that I have. Oh, this isn't times. This is still divided by. Let's leave it as divided by until we factor everything. So 24n plus 24, factor out the 24, and you get n plus 1. And maybe there's an n plus 1 here. I don't know. I have no idea. Maybe there's an n plus 3 as well. You have to keep in mind the fact that this thing's going to flip over. So I have no idea here. But I know there's a 2n and an n here. Maybe a plus minus here. Let's see. If it can't be plus 1. It can't be plus 1 because this would be minus 6. Oh, you know what? I'm sorry. There's a common factor here. Forget it. I'll just factor out the 2. Let's start with this. N squared minus 2n minus 3. I'm so focused on the plus 1 thing, I forgot to check that. Two numbers that multiply to make negative 3 and add to make 1 are negative 3 and 1. So negative 3, minus 3, and plus 1. Okay, there's that plus 1 that we were talking about. Apparently there's no n plus 3. Okay. And I'm fine with the n plus 1s happening here because these divide amongst themselves no matter whether I flip it over or not. Same with the 5n minus 4s. I'm fine with that. Just don't try and divide the 12 by 2 here because this division still hasn't happened yet. Maybe I shouldn't cancel out yet. I don't know if you can trust what it is you can and can't cancel until you kind of play with it all. All right, so 5n minus 4 over 5n minus 4 times n plus 3 times, now I got to flip these, so 2 times n minus 3 times n plus 1 all divided by 24 times n plus 1. So okay, now we see what can cancel. So again, the 5n minus 4's gone, the n plus 1's gone. Now here, listen, 12 12 times 2 is 24. Hopefully you can run with me here. 12 times 2 is 24. 24 over 24 is 1. So all those kind of leave together, right? So I'm just left with n minus 3 over n plus 3. Nothing can cancel there. There's nothing, and I'm done with that. There's my simplified expression. So let's find all of our restrictions here. And again, this is going to be one of those issues where I'm not really sure how to coin n minus 3. I know that it'll be a restriction, though, or it'll present a restriction, because at one point here, this was in the denominator. It doesn't matter that it didn't cancel or anything. So restrictions, n cannot equal 3, one of our restrictions there. Not because here, because there. N can't equal negative 3 clearly, as it's still in the denominator there. That's one of those vertical asymptotes on the graph. And let's find all them holes, the parts that canceled, that would have divided by 0 at some point here. So negative 1. And if 5n minus 4 couldn't equal 0, add 4 divided by 5, that's 4/5. N can't equal 4/5 as well. And I think I got them all. Those are the holes, by the way. Okay, last problem here, number 8. And let's move myself to the side. Number 8, common factor up top of 6r squared. I'm getting a little slower with that. And I have 5r plus 4. Now down below, common factors, no. I'm very curious as to see whether this is 5r plus 4 over here. I'll tell you what, there's good reason to think that it is anyway. Outside of maybe the 10r thing. If this is 5r and 2r, let me at least bring this up. There's at least good reason to think that it could be 5r plus 4. I can't have two even numbers here, otherwise that would give me an even, and I can't have an even there, so it can't be 10 and 2. So it either needs to be 5 and 4, which means the 4 can't go here, would have to go here because common factor, or 20 and 1, and 20 just gets too big, I believe, for this problem. Yeah, it gets too big. So the only chances with this, if it's 5r and 2r, I haven't tested it yet, even in my head to see. So let's try it. 25 plus 8. Yeah, that's 33. So there's the 5r plus 4 is going away. All right, that's good. All right, 3r squared. Now there's no knowing here, but I'll tell you what. The only possibility for this is 3r plus 1 times r plus 1, because 1 is it's not even a prime number, but just 1 times 1 is that, and 3 is a prime number. That's the only possibility there, and that does work. 3 plus 1 is 4. So that's good. So right here, it's possible that I'm going to get an r plus 1 or maybe a 3r plus 1 with this because the 6r squared. So I do like playing with the idea of the strategy here. Let's see. Let's experiment a little bit. Let's see if 3r plus 1 will do it with, this would have to be then 2r plus 5, because 1 times 5 has to give us 5 there. So let's see if that works. 15 plus 2. Yeah, that's 17. That worked out. The other thing I would have considered trying would have been 6r plus 5 times r plus 1, because I wanted to see if the r plus 1s would cancel here, and that would give us 6 plus 5, which wouldn't have worked. But that would have been actually my second attempt at something. I want to try and get things that'll cancel. I mean, what's stopping me from setting something up that's going to work out? All right, let's go and flip that thing over. I mean, is it worth, can you understand things that can cancel out right here? If I don't interfere things together here, these are gone outright. These are gone outright without interference on anything. I'm not trying to divide something here from something here because there's division within that. So let's rewrite what's now there. 6r squared over 2r plus 5. Now we do times, and let's go ahead and flip this. And now we have 2r plus 5 over r plus 1. All right, I have 2r plus 5s on top and bottom as full quantities. Those are gone. And I'm left with just 6r squared over r plus 1. Nothing else can simplify or cancel. All right, restrictions, excluded values. Let's look deeply into this. Make sure you don't forget anything. R can't equal. Even though this flipped over right here, even though, okay, the 2r plus 5 and 3r plus 1's all canceled ultimately. So, okay, all those would have been issues anyway. See, maybe that's not worth canceling to begin with. But 2r plus 5 canceled at some point. That represents a whole then, presents a whole. If 2r plus 5 didn't equal 0, subtract 5, divide by 2. R couldn't equal negative 5 halves. 5r plus 4 is an issue. Subtract 4, divide by 5. R couldn't equal negative 4/5. 3r plus 1 an issue. Subtract 1, divide by 3. R couldn't equal negative 1/3. and r can't equal -1. Now, r can equal 0. There's no problem with plugging in 0 into here. I can divide 0 by something. That's all good. Are there any other issues? The 2r plus 5 is ultimately canceled. We're good there. The r plus 1 I'm taking care of right now. And those are my restrictions. Actually, I have somewhere. Let me check. I have an answer key. I can double check that. Yeah, those are them. All right, guys. So those are the problems there. That ought to do it for this one. Sorry for a bit of the shakiness when I'm talking about it because I'm trying to think how I should best teach it to you. I know how to do it. I want to think of my best approach of showing you what I do to go about this and be as strategic as possible with it. Obviously, they want you to cancel things. That's why I'm looking for those things in the factorization. They seem to clean themselves up. But yeah, hopefully that plays it pretty well. You don't know anything about the holes in vertical asymptotes yet. We'll play with those down the line. Oh, by the way, the r equals -1. Let me present those again. These would have been holes. And this would have been a vertical asymptote here. So you don't know anything about those things yet. I think just me telling you when they are what they are, because when you divide 0 by 0, you get a hole, but when you divide a non-0 by 0, you get a vertical asymptote. I think that's just kind of something for you to just know for now, kind of teasers for later. You don't need to mention that. You don't need to mention that at all. These are restrictions no matter what. You can't plug them in. But graphically, that's what we're going to be seeing. All right, guys, so that'll do it for this one. This is Mr. Robinson. Thank you so much for watching. I hope you enjoyed it, and I'll see you in the next one. Take care.